Right, well these are all the parts for my stepper motor clock. And my intention is to put them all together and explain some of how it works. And I'm just going to tie a knot on that for some strain relief. I get the sense that the knot might take up too much room. I hadn't thought of that before. But okay. There's a cable going into the housing. I did want to make the housing clear so that you could see that there was no microcontroller hidden inside. But I tried to make a clear one and it was awful. Okay, so the cable's in there. Let's put the transformer on. Should we put the transformer on? Should we put the motor in first? I think maybe put the motor in first. You can see this is one of these 28 BYG 48 motors. And it has 5 wires, which is 2 ends of 2 coils and one common. The red wire is common to the centers of both of the coils, but I'm using just orange and pink, which means I'm only energizing one coil. Something like that, whatever, it'll be covered up anyway. Now yes, transformer. Maybe I'll connect those first. Oh, hang on, I'm missing a screwdriver. This transformer is getting 240 volt AC on the primary side and giving us 12 volts AC on the secondary, which is maybe a bit much for this motor because the motor gets very hot. But I did also try a 6 volt transformer and that wasn't enough to make the motor keep turning in the same direction once it started. So we're going with the 12 volt transformer. Obviously I've already assembled most of this, but I haven't put it all together with the plastic box, so it might not fit. Does it look like this might fit on the back? I would say it looks like it might. And before I actually screw the cover on, I'll put the heatsink on the motor. I made this out of an old CPU heatsink, which was a bit wider, a bit longer and a bit taller. Oh, the motor's not screwed in, is it? I think that'll be okay. And it'll get tensioned when the motor is tight. Okay, so this cover can now go on if it will fit. I think we can call this adequate. There is a wire touching the heatsink there, which maybe we don't want. It shouldn't be too much of a problem because the heatsink only gets to about 40 degrees. Without the heatsink, the motor gets much hotter than that. Well, with the mess that's under there, maybe it's a good idea it's not clear. Anyway, good, at least it fits. Onto the front side, we can screw the motor in place. Wicked. And now, one of the features of this clock is that all of the wheels are only supported at the back. They have these little bearing blocks, and the reason for that is so that there's nothing obscuring the view of the works at the front of the clock. So these bearing blocks get pushed into their holes and screwed into place. Good. So that's all the bearing blocks installed. And now we can assemble the gear train, starting with the second wheel because it's the one that goes furthest back. Now on this one, the pinion has a washer superglued to it, and the other gear has 3 magnets in it so that they can slip relative to each other but turn together when there's not resistance. And that's how the hands are set. So that one goes in there. That one goes in there. That's a Geneva drive, but with a little extra feature. So the hook form on the Geneva drive is meant to allow it to turn correctly in this direction, but if the motor starts up in the wrong direction, which we'll do by chance 50% of the time, it will start driving it round, the pin will lodge in the end of the hook and stall the motor, and eventually it will restart in the opposite direction and keep running in the correct direction. It doesn't always work, but that was the idea. This one goes in there. Very good. And then we have, so the Geneva drive thing, the motor goes around once every 10.24 seconds. There are 10 teeth on here. This goes around every 102.4 seconds. I can't remember what the ratio is here. But the shaft here goes round once a minute. Once an hour. That's the minute hand. And then to get the hour hand, we need a shaft that goes around once every 12 hours. So we take drive off here. Oh, and actually, I need to line up the marks. Otherwise, it won't be possible to set the correct time. But we take drive off here onto this sort of counter shaft with the marks lined up, and then off the counter shaft onto another gear which is concentric with the minute hand and holds the hour hand. And then the minute hand will go on there. I won't push it on properly yet because it'll need to come off again. You can see that as the minute hand goes round, the hour hand also goes round. Okay, good. But in fact, that one probably has to come off as well. So that's most of the train. We have these little plastic spring clips that go on the backs of the shafts just to stop them falling out. And then maybe we can go on to fitting the face. So the face is a piece of plywood where the front was painted white and then the markings engraved through the white into the wood. It says on it 50 Hz stepper motor clock, but the writing is so small it could just as easily say 50 Hz stopper meter clock. But that's fine. And there are some dial feet, or I don't know what you call them, standoffs. Then the dial is held on with a couple of screws that go into these threaded inserts. Cool. That's the face installed. Now we can have the hands with the marks lined up. If you don't line up the marks, then you can find that it's impossible to get it to read the correct time. There's about 12. So both of the hands are keyed to their shafts, but there's a bit of play in the minute hand. Well, I mean there's a bit of play in everything, but there's a bit of play in how the minute hand is keyed to its shaft. It looks like it wants to be tweaked around a bit. Oh well, might have to live with that. Okay, good. And so far we can see that when I turn the hands, the Geneva drive thing is spinning around, but if that's held fixed, you'll instead notice this gear slipping because of the magnetic joint. Okay, cool. Finally, we can put the Geneva drive thing on. Now this is locked, and maybe set it to the correct time. What is it? 20 past 1. 20 past 1. Plug it in and watch it go. So the interesting features of the clock are, firstly, that it's powered by a stepper motor without any electronics. The stepper motor is just getting a 50 Hz AC sine wave. So it's acting like a synchronous motor rather than a stepper motor. Obviously, like I said earlier, that means it doesn't actually have a specific running direction. It's running in the correct direction now. But if it were to get switched off, it could start up at a random direction, or if it stalls, it could restart in a random direction. So if I stall it, it reverses, and the intention of the hook is that the motor would stall in the hook and then reverse, but it sometimes takes a few goes. Hey, there we go. Yeah, so that mechanism doesn't work very well. But once it is reversed and it's running in the correct direction, it will continue running in that direction until it loses power, or I manually stall it. So yeah, that's the first interesting thing. The other interesting things, the magnetic coupling we mentioned, and the way that all the works are exposed, because there's no front plate to the frame. The shafts are completely supported at the back. Anyway, that's my stepper motor clock. Thanks for watching, goodbye.